Consider this problem. We have a roller coaster that released from rest at point A. How fast is it moving at point B? So how we can find the speed at point B? We need to use the conservation of energy. At point A, the roller coaster has a potential energy. At point B, all of that potential energy is converted to kinetic energy. So let's set the potential energy at point A equal to the kinetic energy of the roller coaster at point B. So we have mgh is equal to 1/2 mv squared. So we could divide both sides by m, and then if we multiply both sides by 2, we're gonna have 2gh is equal to 1/2 times 2 is 1, so it's just gonna be a b squared. So the velocity is going to be the square root of 2gh. So it's gonna be the square root of 2 times 9.8 multiplied by the height, which is 1.92 meters. So let's go ahead and plug this in. We should get 6.14 meters per second at point B. That's how fast a roller coaster is moving at point B. Now, let's move on to part C. How fast is the roller coaster moving at point C? We're still going to use point A as our initial point. At point A, we still have initial potential energy. At point C, we still have potential energy. Because it's above ground level, it has the ability to fall, and that at point C, it's still moving, so it has the kinetic energy. So we're going to have the same equation. mgh initial is equal to mgh final plus 1/2 mv final squared. And just like before, we could cancel m. So g is 9.8. H initial is still 1.92. Now H final is now 0.04. The difference between part B and C is that we're looking for the final speed now. So 9.8 times 1.92 is 18.8. And that's equal to 9.8 times 0.04, which is 0.392. Now let's take 18.8 subtracted by 0.392. So that's gonna be 18.408 is equal to 1/2 B final squared. Now multiply both sides by 2. So 18.408 times 2 is 36.8, and 1/2 times 2 is 1. So this is equal to the square of the speed. Now let's take the square root of both sides. The square root of 36.8 is 6.07 meter per second. So that's how fast the roller coaster is moving at point C.